On our second example, we are going to do the same thing, and so we are saying that we are going to collect data, and of the data that we have, charge Q1, 2-point charges Q1 is a positive 9 microcoulombs, Q2 is a positive 4 microcoulombs, and the separating distance R is 12 centimeters. What is the magnitude of the electric force? So we'll add up our constant, which is simply 9 times 10 to the power 9. 9 times 10 to the power 9 newtons meter squared per coulomb squared. And so the question is asking us to find the magnitude of the force. So we are saying that force is simply equal to, according to Coulomb's law, K magnitude Q1 multiplied by Q2 over the separating distance squared. So observe that the separating distance has been given in centimeters, and so we have to convert that to meters. And so we are saying that the 12 centimeters that we have, we are simply dividing by 100, and so we have 12 times 10 to the power negative 2 meters, or simply 1.2 times 10 to the power negative 1 meters. The microcoulombs, micro meaning times 10 to the power 6, and so each of these ones is 9 times 10 to the power negative 6 coulombs. This one is 4 times 10 to the power negative 6 coulombs. And so with this data that we have, we are just replacing in this formula so that we get the force. Then be mindful that we made mention that under the calculations as we are doing the force, we have to be mindful that if the charges are the same, if we have like charges, then that is a repulsive force, and the repulsive force is simply negative. And so because this is a positive charge, this is a positive charge, so the force between these two charges is a repulsive force, and so the force that we are going to get is going to be negative. And so let us substitute and see what we actually get. So we are saying that the Coulomb's constant, 9 times 10 to the power 9. We'll skip the units. No, let's write them so that we are mindful. Multiply by 9 times 10 to the power negative 6, multiply by 4 times 10 to the power negative 6. When the units there is going to be Coulomb squared over the separating distance, the 1.2, times 10 to the power negative 1 squared, so meters. And so if we do the evaluation there, we have 9 times 10 to the power 9 multiply by 9 times 4 gives us 36, then times 10 to the power negative 6 and times 10 to the power negative 6 all have a common base, and so we add the powers. So we're going to get a negative 12 over 1.2 times 10 to the power negative 1 gives us 1.44 times 10 to the power negative 2, the power negative 2. And what we are getting is going to have a unit newtons, and so all that is required for us is to simply finish up. So we are saying we'll have 9 times 10 to the power 9 multiplied by 36 times 10 to the power negative 12 over 1.44 times 10 to the power negative 2. So we'll isolate these ones, newtons, as our as our units there. So we'll have 9 times 36 over 1.44 times 10 to the power 9 plus negative 12 minus negative 2 newtons. And so what we are then getting there is, if we multiply 9 times 36, we get 324. Then that answer divide 1.44. This gives us 225. Then times 10 to the power. So we have 9 minus 12, then plus 2, giving us negative 1 newtons. And so writing that, we are simply going to have 22.5 newtons. This is the force. Now remember that this is a repulsive force, and so all repulsive forces are negative, and so that is our final answer.